Welcome to the deep dive. So today, we're doing something a little different. We're looking at just a single source.
Yeah, but it's a really dense one. It's a product specification sheet for the Thor Broadcast F-2VD-TXRX.
Exactly. And our mission really is to unpack the engineering here, to understand how you transmit high-quality signals over, well, truly massive distances.
And what we're looking at is an analog video optical extender. It's built for the CVBS system.
That's the old analog standard, right? Composite video.
That's the one. And its core function is to take two separate video sources and push them down a single fiber optic cable. It's all about efficiency.
And the scale is the first thing that just jumps off the page. I mean, the base unit supports 20 kilometers, which is already a lot, but
But then you see the extended models.
40, 80, and then 120 kilometers. That just seems almost impossible for an analog signal.
Right. I mean, that's roughly the distance from London to Bristol through the air.
It tells you right away this isn't consumer tech. This is for, utilities, long-range surveillance, something huge.
Exactly, where signal integrity is completely non-negotiable.
Okay, so if you have equipment 120 kilometers away, you absolutely have to be able to control it. So how do they handle that? Is it some new IP standard?
You would think so, but no. And that's what's so fascinating here. The system uses these classic, highly reliable legacy standards.
Like what?
RS-232, RS-485, RS-422. This control data is actually sent from the receiver all the way back to the transmitter.
So if you're watching a camera feed from that far away, you can actually pan, tilt, or zoom it.
Precisely. And using a protocol that's been around forever because it's so robust, the RS-485 uses a simple terminal block. It's built to last.
And it handles both full duplex and half duplex.
It does. So it can handle simultaneous two-way data or just one way, depending on what kind of gear you've got hooked up.
Okay, so let's get to the video itself. It comes into the box on two BNC connectors, which is, the standard for this stuff.
The old reliable.
But what are the specs that guarantee that signal actually survives the trip?
So if we look at the sheet, the video bandwidth is 8.0 megahertz. But the key, I think, is the quality guarantee. They use 10-bit quantization.
Which is a real step up from the usual 8-bit. That helps with color banding, right?
Absolutely. In a surveillance scenario with lots of shadows and bright spots, that 10-bit depth preserves all the crucial detail. You don't get those ugly stripes of color.
And what about the clarity? Is it just a fuzzy mess?
Not at all. The signal-to-noise ratio, or SNR, is listed at greater than 67 dB.
And for you listening at home, that means the signal is over 500,000 times stronger than any background noise.
It's an assurance of a crystal clear image, even after that huge journey.
Speaking of clarity, something else stood out. For a video extender, the audio specs are surprisingly high-end. Why?
I think it's because the environments this is used in are so high stakes. The audio isn't an afterthought. We're talking 20 hertz to 20 kilohertz bandwidth.
The full range of human hearing.
Exactly. And it's using 24-bit quantization, which is professional broadcast depth. The audio SNR is even higher, over 75 dB, with distortion under 0.1%.
So basically zero added noise or interference. You could probably use it for forensic audio monitoring if you had to.
You really could. And finally, they add a few things for the people actually buying this. It ships with the latest firmware, has a 1-year warranty.
And it's TAA compliant.
Right, and that's crucial. TAA is the Trade Agreements Act. It means it's made in the U.S. or an approved partner country, which is a requirement for a lot of government and defense contracts.
So let's sum this up. We've basically broken down this highly specialized system that flawlessly combines two analog video channels
And that bidirectional control data.
onto a single optical fiber and keeps it perfectly clear over distances that are, frankly, hard to even imagine, up to 120 kilometers.
But this all raises a really interesting question for you to think about. What fundamental shift in our communication infrastructure has to happen to make this kind of performance, 120 kilometers of uninterrupted high-quality video and data, a common everyday consumer expectation instead of something that's reserved for these specialized industrial solutions?
Yeah.
What would it take for that to be normal?